Today's lesson we're going to talk about similarity in right triangles. Um, so our learning target is going to be you will use properties and relationships in similar right triangles. Okay, first concept we're going to talk about is something called the geometric mean. And to find the geometric mean between two numbers, it's two steps. Number one, you're going to multiply the two numbers together. And number two, you're going to take the square root of that. So let's try some examples. All right, so for number one, we're going to find the geometric mean between 4 and 9. So we're going to multiply those together. 4 times 9 is 36. And then we're going to square root that, and we get 6 as an answer. Number two, okay, 3 times 48. That's going to be 144. And then we're going to square root that, and we get 12. Now we're going to talk about similarity in right triangles. If you have a right triangle and there's an altitude drawn, in this case, this segment right here is called the altitude of that right triangle. What it does is it splits that right triangle into two other right triangles that are similar to the original. Okay, so there's the right angle. Now, to figure out any missing lengths in this case, this side right here is labeled X. First thing we're going to do is we're going to redraw these triangles all facing the same direction. So I have the small triangle here, I have the medium, and then the big one here is the large. Okay, so the small triangle would look like this, and the short leg is 4, the long leg is 6, and the hypotenuse is not labeled. The medium triangle, which is the one on the left, would look something like this. The short leg is 6, the long leg is X, and the hypotenuse is not labeled. And then we have the large triangle, okay? The large triangle, the short leg is not labeled, the long leg is not labeled, and the hypotenuse would be the expression x plus 4. Now, out of these three triangles, which are all similar to one another, I can now set up proportions to find that missing side. Now, I notice that these two sides correspond to these two, so those are the sides I'm going to use to set up my proportion. So I'll go 4 over 6 equals 6 over x. And now just simply cross multiply. So 6 times 6 would be 36 divided by 4. X would be 9. And that's how you use similar right triangles to find missing lengths. Now we're going to do the same thing over here. Again, we have the small triangle, the medium, and then the large is the outside triangle. So I'm going to redraw them facing the same way. Short leg, long leg, hypotenuse. Short leg, long leg, hypotenuse. And the bigger one, short leg, long leg, hypotenuse. Okay. The small triangle, the short leg, here's the right angle. The short leg is 4, and the hypotenuse is x. The long leg is not labeled. The medium triangle, the long leg is 5, and the large triangle, the short leg is x, and the hypotenuse would be 4 plus 5, which is 9. So, again, knowing that these triangles are similar, I notice that the small triangle sides match the large triangle sides. So that's what I'm going to use for my proportion. I'd take 4 over x, and then equal the same thing on the other side would be x over 9. When we cross multiply here, x times x is x squared, and 4 times 9 is 36. And to undo that square, I'm going to square root 36 to get my missing length, which is 6. Okay, a couple more examples. Again, the small triangle, draw that out, small, medium, and large, all facing the same direction. So the small triangle, Here's a right angle. The 4 would be the short leg. X would be the hypotenuse. Okay? The medium triangle, which is right here, the long leg is 21, so that goes down there. And then the big triangle, the short leg is X, and the hypotenuse would be 21 plus 4, which is 25. All right? And I can see that these are the matching sides, so that's going to be the information I use for my proportion. So 4 over X equals X over 25. And we cross multiply again. X times X is X squared. 4 times 25 is 100. And square root 100 to solve for X, and we get X equals 10. Okay, last one. Same concept, same routine. Small, medium, and large. So my small triangle, medium size, and the large. Small triangle, here's my right angle. Short leg is 3, nothing else is labeled. The medium triangle, 9 would be the long leg, X would be the hypotenuse. And the large triangle, X would be the long leg, and 3 plus 9 is 12. 12 would be the hypotenuse. So looking at the medium triangle and the large triangle have matching sides, so that would be my proportion. So X over 9 equals 12 over X. And we're going to cross multiply. X times X is X squared. 9 times 12 is 108. We're going to get rid of that squared by square rooting 108. Okay. Now in this case, 108 is not a perfect square. So I need to simplify this in radical form. So again, I'm going to think of a perfect square that divides into 108 evenly. 36 would be that number. So 36 is my perfect square. And 36 times 3 would give me 108. So the square root of 36 is 6. And the square root of 3 tacks on to the end. So that it would be my final answer for X. That concludes the lesson on similarity in right triangles. Have a nice day.